Okay, we will prove in this theorem that the complement of A intersect B is the same thing as the union of A complement and B complement. Now we will do this using the standard technique to show that two sets are equal. So we will show that the left side is a subset of the right-hand side, and we will also show that the right-hand side is a subset of the left-hand side. So this is going to be a blue light special, that 2 for the price of 1. To show that two sets are equal, we usually have to show two different things in order to show that two sets are equal. Okay, so first direction. So first we're going to show this direction. Suppose that x is an element of the left-hand side. If x is an element of this set complement, that means that x is not an element of the original set. X is not an element of A intersect B. So it is false that x is an element of A intersect B. In other words, it is false that x is in A and x is in B. That's what it means to be in the intersection. If x is an element, and if it's false that x is an element of A intersect B, then it's false that x is in A and x is in B. So if this is false by De Morgan's laws, it is true that x is not an element of A or x is not an element of B. The negation of x is in A and x is in B is that x is not in A or x is not in B. Therefore, if x is not in A, that means x is in an A complement, or if x is not in B, that means x is in B complement. We conclude that if x is in A complement or x is in B complement, we conclude that x is in the union of those two things by definition of union. And so that is the proof of one direction. To do the other directions, A complement union B complement is a subset of A intersect B complement. This is going to kind of unwrap the one that we just did. So suppose that x is in A complement union B complement. Then x is in A complement or x is in B complement. That's what it means to be in the union. Therefore, x is not in A or x is not in B. So this is a true statement, so it is false that x is in A and x is in B by De Morgan's laws. This statement is true, and so that means the negation is false. In other words, it is false that x is in both sets, which means that x is in the intersection of the two sets. Therefore, we conclude that x is not an element of A intersect B, or that x is an element of A intersect B complement. So it's false that it's in the set. That means x is not an element of A intersect B, which means that x is an element of this set complement. And so we've shown that the left side is a subset of the right. The right side is a subset of the left, and so therefore the two sets are equal, and that concludes the proof.